Hey guys, my name is Sandeep Patel. I'm the founder of Slottify.ca. So in this video, we are particularly focusing on the array data structure and specifically updating operation, like how many different ways we can update an array, right? So that is all about. All right, so let's say that we're given an array like this, right? And the question is how many ways we can update this array, right? We know that array has indexes, right? Which start from 0 until n, and then array also has a length, and this is element, right? So these are all elements. So there are two ways we can update an array, right? You can either update by element value, right? Or you can update by index, right? So for example, let's say we want to update, let's say index 4, right? So instead of 5, we want to update it with 10, right? So how do you do that? So you grab that index and then you replace the existing value with your new value. So that's one way of doing by index. And there's another way you can do it by value. So let's say we want to replace number 5, so value 5. In that case, what we had to do is we had to loop from 0 until we find that particular value, right? So let's say we are traversing from 0 until we reach to index 4, where we compare, okay, at this index what is the value, right? And if we find that value with the target value that we want to update, then we can change, right? So in this case it's updating by value, right? So I have the time and space complexity. So in this case, when you update by value, the time complexity is O n, and when you update by index, it's O1. And how do we come up with this? So let's explain this in very depth, right? Let's take a look at this example. Alright, so I have an example here. So I have a sample array, right, which is a number. It has 10 different elements, right? It has 9 elements in this array, and we have these two functions. So first function is update by index and update by value, right? So let's first work with update by index. So how do we update array such that we have given index and the value that we want to replace? So how do we do that, right? So we call this function update by index here, right? So let's do a console log first. So this is before we perform update operation. I want to check what's in the array, right? Okay, so we got this array which has elements 1 to 9, right? And I printed before we want to write a single line of code, right? Okay, so what is the best way to update array by index? So you know that, like, you grab the array and you try to find that by index, right? And then you replace with the new value, right? So this is a simple way. In one line you can update a new value by finding the index, right? So this is a single statement, right? And we will log our new array after we updated the index. Okay. All right. And now you can see before we had this array, and then what we did is we wanted to update index 0 with value 10, right? So this is the index 0, and then we updated with the value 10, right? So this is how you can do a update by index, right? So what is the time and space complexity of this program, right? So we're going to remove the console log because actual logic is like one line of code, right? So in my previous tutorial where I explained time complexity, when we are calculating the time complexity is, so we see like how many statements are there in our algorithm, right? So basically in this function we have only one statement, right? So when we run this code, what happens? to this statement, like how many times this statement runs. So we can clearly tell that like when we call this function, this code runs only single times, right? Which means we can consider this as 1 unit of time, right? So let's say this piece of code is running at 1 unit of time, right? And when we consider big O, so big O concerns about what is the worst complexity of your program, right? So in this case, because we have only one line of code, and because it's running only 1 unit of time, the complexity would be O of 1, right? And how about the space complexity? It would be the same. Why? Because we're not using any additional variables. We're just mutating the input variables, right? And when you try to find the space complexity of program, you just ignore the input mutation, right? We're not using any extra variables. We're not calling any other call stack. We don't return anything here. So that's why if you consider this line of code that is running in 1 unit of space, right? When this program runs, this occupies 1 unit of space, right? Because we're assigning a new value, but because we are assigning value to existing input, we ignore this. But we can still say, okay, it takes like O of 1 space, right? Alright, so let's do update by value, right? So when you want to update by value, what do you need? So in this function, when you want to update by value, you pass in an array the existing value that you want to update. Let's say we want to update this new added value, right? 10 with its original value 1, right? So how do we do this? Like, we can't do like this, right? Because we don't know index, right? We're updating by value, right? We can't say, okay, array and then value and then update by value, right? We can't do that because it's gonna update wrong index, right? Okay, so in this case, what we'll do is like we will run a loop which runs from I equals 0 until I less than array.length. Right, and I plus plus. Okay, so this is a very simple code where we are running loop from 0 until the input length, right? The input is array and until array length. You can also separate this out for better readability. You can say, okay, we create another variable and which occupies array length, and then you can say our loop runs from 0 to n, which means it takes n iteration, right? And now within this, how do you find the element, right? So to grab the element, you can say, okay, constant element equals array, and now we have indexes, right? This I is the index. So now what we do is we take this element and compare it with our old value, right, that we are passing. And when we find that element, we want to replace it. We want to replace that index value with our new value. And when we do that, you can return here, right? You don't want to continue, right? So in this case, what happens is we have this array 1 2 3 1 to 9, right? And then we call this update by index function, right? We updated with value 10, so that's the output. But now that we also wanted to update by value, so we're reverting what we did here, right? So we want to find where the 10 is, which is at index 0, and then replace that value with 1. So what happens is when this loop runs, right, from 0 to n, so what's in the first position? 10, right? And now we're comparing 10s against our old value, so we want to find 10. So 10 equals 10. In that case, we find the first part here where by value, and now we want to update with the new value, right? So what's the new value? 1, right? And then there's no point of continuing the continue to going on the next element, right? Just so that we can save some time here, right? Okay, so that is how we can update by value. Let's look at before and after. Console.log before, and then once we update by value, we also want to check after. Okay, right, I don't know why it didn't run this second line. Oh, because it returned right here. Okay, so I'm gonna take this return out just so that we print the array. All right, so before it was this array, right? And the first index has a 10 value, right? Which we replace with 1, right? So that is it. And to calculate the time and space complexity of this function, what we do is we will find out how many operations we are doing, right? So this is statement 1, right? This is statement, you can also say there's also a for loop, right, which runs n times. So when you're calculating the time complexity, you have to pay attention when you encounter the for loop, right? And especially to check if the for loop depends on the input, right? So right now it's starting at 0, and it does depend on the input size, right? For example, if array length, let's say if there are 5 elements, then it's going to loop until 5. Maybe this one has a million elements, then this for loop will grow from 0 to million, right? So you have to pay close attention here. So all the statement within the for loop will be multiplied, right? So for example, this if statement, right? Let's say that this is running in 1 unit of time, right? So now this whole thing, let's say this is also 1 unit of time, this is also 1 unit of time, right? So when this loop runs, it's gonna run until n. So all this 1 unit of time will also multiply into n. So basically, if we try to find the complexity of this for loop, overall complexity of this for loop will be O of n. Why? Because there are n iteration happening, and there is 1 unit of time happening within the for loop, which multiplied into n times. So this will grow linearly, right, with the input size. So that's why you can say, okay, the time complexity of this code is O of n. How about the space complexity? So in space complexity, we're concerned about the variables that are dependent on input, right? So for example, this is a variable, right? But it's not dependent on the input, right? It's not growing with the input size. This is fixed. Like for example, if array has 9 elements, we're storing n equals 9, which is fixed, right? It's not increasing. If you run this code 1 or maybe 100 times, it doesn't matter. This will have a static value, right? So you can consider this as 1 unit of space, right? We also have another variable here, right? But this is an input variable, right? We are mutating input variable which we don't count towards the time complexity, space complexity, right? So in this case, we can say, okay, the space complexity is O of 1, right? But with input, if you count the space complexity with input, then you can say, okay, it takes O of n. Why? Because it is multiplied, right? This line of code is multiplied n times, right? And this variable is mutated n times, right? So with input, it's on, and without input, it's O of 1. I hope you like this video. Please like, subscribe, and stay tuned for my next video on array.